Hi guys, in today's video we'll be learning a fundamental concept of JavaScript called as closures. By the end of this video, you'll understand what closures are, how they work, where you might use them, and some of the pitfalls that you might fall into while using a closure. Let's see the textbook definition of it. A closure is a function that retains access to its lexical scope even when the function is executed outside of that scope. To understand closures better, let's look at a function. First, we create a function called as outer function, which holds a variable called as outer variable consisting of value hello world. Next, we create another function called as inner function that does nothing but console log the value of the outer variable. And finally, we return the inner function. Now, when we create an object of outer function, let's say my closure, and when we called my closure, it will print the value of outer variable as expected. Here we have an outer function that defines a variable outer variable and an inner function that logs this variable to the console. So the key part is when outer function returns the inner function maintains access to the outer variable even after the outer function has finished executing. This is a closure. This is what we meant by when we said that it retains access to its lexical scope even when it is executed outside of that scope. Now we know what a closure is, so let's look at a real world use case of it. Let's create a simple counter. Now there are multiple ways of creating a counter, but since we're on the topic of closures, let's create one by using a closure. So first we create a function called as create counter that will hold a variable called as count. So let count equals 0. So the initial state is 0 and finally we return a function that will increment the variable of count by 1 and then return that value. So return function count plus equals 1 and return count. Now when we create an object const counter equals create counter, the number of times that we use counter, it will increment the value one by one. So we do console.log counter 3 times. So as expected, the output will be 1, 2 and 3. Now in this example, create counter returns a function that increments the count variable and returns the new value. Each time we call counter, it is remembering the state of count because this is a closure. Closures are also incredibly useful in an asynchronous code. Let us see how they work with a common example using set timeout. So what I want to do is I want to pass a message and finally print it after its delay of a specified seconds or milliseconds. So we can create a function called as create delayed logger that will accept two parameters, a message and a delay. And finally, it will return a function that will console log the message after the specified delay. So set timeout and then we create the function. And finally, we have passed on the specified delay to it. Now here if you see the delay and message are variables of the outer function, but they are accessible to the inner function as well. Now let's create an object const logger equals create delayed logger. Let's say I want to print hello world after a timeout of the two seconds. And then we call the logger. Here create delayed logger returns a function that logs a message after the specified delay. The return function forms the closure, capturing the message and delay variable even though set timeout executes later. Let's look at some of the pitfalls. While closures are powerful, they can also lead to some common pitfalls. So let's create a for loop that I want to print values 0, 1 and 2 after a delay of 1 second. So I'll use set timeout in which I use console log I and I pass the delay as 1 second. In this loop, we might expect it to log 0, 1 and 2, but it logs 3, 3, 3. This happens because the var keyword is a function scoped and the closure captures the same I variable. Now since we have given it a delay of 1 second, while the for body is in delay, the value of I is being incremented. Now we don't want that. We first wanted to print the value and then increment it. So for that, instead of var, we can use let. Now since let is a function scope and the closure captures the same I variable, to fix this, we can use let, which is block scoped. Now this is because while the set timeout is being executed, during that timeout, the value of I automatically gets updated and we don't want that. So if we use let instead of var, it will first execute set timeout. It will wait for 1 second, print it and then update the value. So guys, that's it for closures. So today we learned what closures are, how they work and where they can be useful. Closures are a powerful feature in JavaScript and can help you write more efficient and concise code.